Hello everyone, my name is Bhushan Sunil Mahajan from last year student in Sandeep Institute of Technology Research Center, Nashik, Maharashtra. My teammates are Makrand, Navnath, Dhule. We are here to project on microwave oven simulation which we'll have done in this internship contained by Emertxe Technologies, Bangalore, and also must be internship provided by Emertxe Technologies in Bangalore. Next we'll show table of contents. Let's see introductions about the project, then let's see the cooking modes and tools required to be installed, then topics learned during this internship, then embedded system and microcontroller and microprocessor, then PiximLab architecture, then syncing and sourcing circuit, then CLCD, then tactile switch, then matrix keypad, then interrupt, then ISR, then timers, then conclusion, and last one is project demo implementations. Oh, okay. So firstly, we introduce what is a microwave oven. The microwave oven is used to heat the food and for the cooking purpose using microwaves, which is form of electromagnetic waves. There are several modes in various microwave oven, such as here we are going to implement four cooking mode. They are such as follows: micro mode, grill mode, convection mode, and last one is start mode. Let's see the cooking modes. The first one is micro mode. In this mode, we have to set power level of cooking in which heating is done by microwave, and we have to implement such a system that will set cooking times in micro mode, and after completion of given time it have to given alert. It uses a maximum power 900 watt. It is the micro mode. The second one is grill mode. In this mode, we have to set up timer for cooking by presenting keys. We have several keys on board to have to set different function to different keys. This mode is used to cook meat and bread or other food items. Convection mode. Convection mode enables you cook food in the same way as in traditional oven. We can set the temperature as required in a given range. It takes 180 seconds to preheat the oven. We have to keep door closed. If the door is open, it have to give alert and turn on the buzzer and turn off the fan. This is the convection mode. And the last one is start mode. After selecting this mode by presenting key in the matrix keypad, the cooking starts is automatically. And the requirements tool. The requirement tools is firstly as MPLAB X IDE, then X8 compiler, and then PiximLab simulator. In the PiximLab simulator, these are in the important things will be represent in PiximLab. Is such as a X8 compiler is it's also a compiler and we present in microcontroller PIC 16F877A, then LCD 16 into 4, then tactile switch, then a matrix keypad and timer 2. The things will be represent in PiximLab. This is the important in PiximLab requirement tools. Then embedded system. Embedded system is a combination of any hardware and software which is intended to do a specific task. A general purpose system (GPS) is used to perform large number of tasks, whereas an embedded system (ES) is used to perform a specific task. Types of embedded system. The types of embedded system, each first one is standalone system, second real-time system, third network and mobile, third network, and last is mobile. And it is also the components of embedded system. This is the first one is memory, and this is the system core, and then input ports and other devices such as the embedded system devices and the output ports. It is the component of embedded system. Firstly, introduce the classification in embedded system, which first is standalone system. The first one is the type slave system. The system are not intelligent even though these are embedded system. This system cannot take action by their own. Example, this is a semi-automatic washing machine. It's just a semi-automatic washing machine. And the second one is independent system. This system can take action by their own. Example, Google car in driverless car. It is also used in independent system in Tesla car. This is the automatic Google car, driverless car. And then classification in real-time system. These system are time-bound system which will take actions on specified time. Failures in this system are not acceptable. This is the uh, classified as hard real-time, firm real-time, soft real-time. Example in airbag system, such as the airbag system. Network system, the network system which are connected to the network. Example, home security system. 4 is mobile system. The system which are movable are called as a mobile system. Examples such as the robots. Network system, this is the network system are connected to the network. And after we see here we'll see the software is a microcontroller, and this is the all in UC or SOC or UP in memory, FGPA and SC, and this is the diagnostic port and the ADC, analog to digital converter. This is a human interfaces, digital to analog converter. This is the actuator, sensor, and auxiliary in system power and cooling. The features of the software in it also include memory and actuators in the software block diagram in microcontroller. Next, how to choose an embedded system. The choose on embedded system such as the basic things in low power consumption, second cost efficiency, third one is efficient use of processing power, fourth one is reliability, and fifth one is efficient uses of memory. Okay, we will see next microcontroller and microprocessor. This is the comparison actually, and an integrated circuit which is capable of being programmed to perform a specific task and specified task. It has a design restriction such as a memory size, I/O capabilities, and peripheral functions, etc. And third one is choose a microcontroller based on application, performance, price, availability of tools, and special capabilities. Okay, so microcontroller and microprocessor. The difference between here we can microcontroller and microprocessor. Microcontroller, all components will be a single chip. This is the single chip microcontroller and less flexible and less design complexity. And the second microprocessor, all components are assembled to separately. And the more flexible and more design complexity in microprocessor, such as a iconic chip into design complexity. Okay, the next one is PiximLab architecture. The PiximLab architecture to show that PIC 16F877A to the shown in PiximLab architecture in RS32, LEDs, buzzer, digital keypad, SSD, matrix keypad, and CLCD is also shown in analog to digital converter in CLCD display to such as a temperature sensor in use to CLCD in GPIO I2C and then RTC EEPROM and LM35 temperature sensor ADC. It is used as a, such as a PiximLab architecture in components and such as the LEDs, buzzer, digital keypad, SSDs are used in this PiximLab architecture. The next one is syncing and sourcing circuit. This is the two types and current sourcing and current syncing. Okay, the current sourcing, it is the current flows out of device and the current syncing in current flow into device. This is the current sourcing left diagram and current syncing in right. Such as a current sourcing, here the microcontroller acts as a which is input to the load, which is input to the load in current sourcing device to the automatically current flows out of the device. And the current syncing the device in in current syncing microcontroller such a acts as a load which takes input from the source. which take input from the source in current syncing device load. So automatically current flow into device. This is such as a explanations of current syncing and sourcing, current syncing and current sourcing. The next one is CLCD. CLCD is character liquid crystal display. Most commonly, it is used to display ASCII characters and some special characters. The communication modes of CLCD is 8-bit mode and 4-bit mode. In display of ASCII characters is a American character actually, and some special characters. In Pixim Lab, there are two types of display. Is first one has 16 into 2 display, and then is 16 into 4 display, and this is the CLCD. Is actually where it is the how to character liquid crystal display is shown. And then tactile switch. We will see in tactile switch which can observe pull down resistor circuit and pull up resistor circuit. Pull down resistor circuit switch is a open and then control is read R1. Means actually controller, the switch is open and then control read to R1. And the switch is closed, control is automatically read to 0. The switch is closed, the controller read to automatically is 0. This is the work is pull down resistor circuit. And the tactile switch is the next one is classified pull up resistor circuit. The switch is open, the controller read to it must be 0, and if the switch is closed the controller read to VDD. It is VDD, and this is the classifications of like all other switches, tactile switches in a control circuit. This is the two majorly impact in pull down resistor circuit and pull up resistor circuit. The next one. So, okay, the tactile switch is switch whose operation is perceptible by touch, and then the switch is used to select the mode of operation and to enter the temperature and to enter the time in our project. The switch will produce a bouncing effect when a switch is pressed. The next one is matrix keypad. The MKP is a matrix keypad, and this keypad is which number of tactile switches are connected in row and column concept. This is used when more numbers of user inputs are required and still want to save some controllers I/O lines. These keypads are mostly commonly used in telephones, calculator, digital locker, etc. Here, matrix keypads, there are is features also rows and columns must be matrix keypad. Then interrupts. And interrupt. Okay, next we'll see interrupt. Interrupts is a communication process set up in a microprocessor or a microcontroller in which an internal or external device requests at the MPU or MCU to stop the processing. Then the MPU and MCU acknowledge the request and attend to be the request. Goes back the processing where it was got interrupted. Disadvantages in the interrupts, poor response, less power management, etc. And the classifications are the interrupts are classified mainly divided into hardware and software, such as a hardware in classified as a non-maskable and maskable, and also maskable is further classified into external device interputs and internal device interputs, such as the ISR interrupter service routine. ISR is an interrupter service routine, and ISR is a software routine that hardware invokes in response to an interrupt. ISR attends to the request of interrupting source by clearing the interrupter flag and should save register contents that may be affected by the code in the ISR. It must be terminated with the instruction RETIE, and when an interrupt occurs that MPU completes the instruction being executed, then it disables global interrupt enable, places the address from the program counter on the stack, return from interrupt. The timers. Timer is an important application, is an embedded system, which is default peripheral which maintain the timing of an operation in a sync a system clock or an external clock. It has many applications such as measuring and generating time and generating delay, etc. Timer counter is a software designed to count the time intervals between the events. Resolution which is called register bit, such as 18 or 16 bits, etc. TIC is referred as the change from the number to the another number. It may be up and down count. Quantum which depends on the system clock settling is a measure of time which is responsible for the tick. Scaling may be pre-scalar or a post-scalar, maybe it's 1:1 and then 1:8, etc. Most of timers are counter, it's pulse with modulations or pulse generator, etc. Let's get into the project demo, which will be done by Makrand Dhule. Thank you guys. And the project demo which will be done by Makrand Dhule in next. Thank you everyone.
Hi, myself Makrand Dhule, currently pursuing B in Electronics and Telecommunication Engineering at Sandeep Institute of Technology and Research Center, Nashik. Now I see the demonstration of microphone project. This is the software for compilation of the project code. This is overall project code. You can see this is the code for the project of microphone control. Let's build it. I right click on microphone project, build it. Now you can see build is successfully and also the X file is created. Uh, this is the path for the X file. Now let's load it into PixSimLab for the simulation purpose. Open the PixSimLab, reload last. X file is reloaded into microwave. You can see powering on microwave oven. Then display the cooking modes. This is the 4 mode for the cooking. Micro grill convection start by pressing 1, select micro mode. I select micro mode, press 1 key for it. It shows the power 900 watt. For the cooking purpose, you select set time. I set time 30 seconds. By pressing star key, you can clear it. Also set it. I set 20 seconds. By pressing hash enter it in. Now you can see fan is running. Microwave is working. By pressing key number 5, you can pause it. By pressing number 4, you can resume it. Also, you can by pressing number 4 increase the time by 30 seconds. Fan is running. cooking is going on. After the time is completed, buzzer is on. You can see time up. Now set the time for the grill mode. Select it by pressing key 2. I set 5 seconds for it. Enter. After the time is over, is gone on, and alert it by pressing buzzer. Now see the convection mode by pressing key number 3. Set the temperature for the preheating purpose. I set 180. Enter it. You can see preheating time is processing. It's nothing but 3 minutes. Now countdown is processing. Now wait for the time. 'After this time is up, buzzer is on, an alert to the people. The preheating time is purpose for the safety of the microwave oven. Wait for the time. 15 seconds remaining. 2, 1, 0. Now you can set time for the cooking purpose. I set time 10 seconds. Enter it by pressing hash key. A fan is running. By pressing number 4, you can directly start microwave for 30 seconds. See it. Time is start from 30 seconds. You can stop it by pressing number 6 key. Stop it. This is the overall project demonstration of microwave oven, and thanks to Emertxe for providing this internship. Thank you.